Hi, in this video, we want to take a look at detecting bias in questions on a test. All right, so this is called differential item functioning. And what we're trying to do, we're trying to find or try to measure how much is there like a difference between different groups on an individual question on a test. This way we can identify potential bias in our questioning and try to improve them. All right, so why do we do this? Well, first and foremost, we want to improve our test questions. If we're going to reuse a test question and it's biased, that's a bad idea, right? So if I have a biased question, first of all, I can throw it out and never use it again. I could modify it and rewrite it, identify, using subject matter knowledge, identify why the question is biased, and then fix it. Now, another reason why we'd want to do this is so that those who write test questions get feedback on their own work. Okay, and so this is very important because if we have people who are writing biased questions and they don't know they're writing biased questions, how are they going to improve? This is part of the process of making a good, reliable test and having like a feedback loop so that those who write the test and author it and review it have knowledge into the potential pitfalls that they may or may not have stepped into. All right, the examples that I'm going to go over are modern psychometrics with R from the Springer series. Here is the website for the original code. This is modified. All right, so in our first type of modeling, we're going to use logistic regression. We're going to have 4 different models to consider. First one is the constant model, and there the probability of being correct has nothing to do with the factor, has nothing to do with the subpopulation covariate. Next one is going to be the logistic regression model that uses just the factor, okay? So here, this gives us an idea of the likelihood of getting it correct given the student's overall ability. All right, so if the factor is informative to the student's level of proficiency on that test, this model should be statistically significant when compared to the constant probability model. The third model we're going to think about is that we're going to have the factor like we had in the previous one, but we're also going to include a subgroup covariate. Okay, so if we have bias in our system, this model that has that has a factor and a group in it should be statistically significant when compared to the model with just a factor. And the last one we're going to look at is where we have the factor, we have the group, and we have interaction between those two, and that's our last model. Okay, so if we do not have the interaction term, or here we have a main effect from group, then we're going to call that uniform differential item functioning. And so there, when I look at the logistic regression curves, they're going to be shifts of each other. And so you can think of it like each subpopulation gets its own intercept in the logit model. Non-uniform differential item functioning is where it's shifted, but also we have a different slope. In the uniform version, we have parallel logit curves. In the non-uniform version, we do not have parallel logit curves. They shifted, and we're going to have potentially places where they cross each other. All right, so let's go ahead and take a look. We're going to use the youth depression data set. And here are the individual items so that, if you want to, you can dig in. Now, I'm going to limit the output to 2 digits so I don't get blasted in the face by numbers. I'm going to load the data from the MPsychoR package, and I'm going to get rid of the race covariate. Now, on this part of the code was actually redundant. There was something I was doing and I forgot to delete this, so I'm just going to leave it. Don't let anyone know I did it. All right, so now I'm going to build the logistic regression models. Okay, so remember I said that we have 4 models going on. We have a constant, and then we have the model that includes the factor. Then we have the model that has the factor and the group. And then we have a model that has the factor, the group, and the interaction between those two. All right, so we're going to get a lot of output. I'm going to get a whole bunch of p-values. The first column checks to see if the factor is statistically significant, or the factor model is statistically significant when compared to the constant model. All right, if the factor is coherent in telling us information about the individual item, this will be statistically significant. The second column checks to see if including group, if adding group to the factor only model improves the model. All right, so if adding group improves the model, we conclude that there is bias, uniform bias in our modeling. Now, the third column checks to see if the interaction term is statistically significant. All right, so if this is statistically significant when compared to the main effects model, then what we've got going on is we have non-uniform differential item functioning. We have non-uniform bias. So let's build the model, and we're going to use the L ordinal if function, Lord if function in the Lord if package, and we can get our output. All right, so this column is a bunch of p-values saying, hey, for this individual item, is the factor only model better than the constant? So here we can see that for our very first item, the constant probability model is the one we would want to go with. But when I get down to this line, I can see that what I would choose the main effects model with group, but I would not choose the one with interaction term because this is not statistically significant. Here, we would choose the model with the interaction term because all three are statistically significant. And we can go in and check each of the individual items. So something to realize is that for each individual item, for each question, I have multiple logistic regression models that are being evaluated. Now, if I want to start looking at the parameters, what happens here is that this is the intercept in the logit equation. This is the slope of the factor, and sorry, no, this is the slope of the main effects model, and this is the slope for the interaction term. And if I want to get individual factor estimates, I use theta, and this gives it to us. Now this next part, this is actually a really nice visualization, but I couldn't get it to run on R Markdown. But if you run this section of code, you'll see some very nice logistic regression curves that show you visually what our conclusion is in terms of the differential item functioning. Now, another option I have is to use a tree model. So in the tree model, what it's going to do, it's going to evaluate, should we include the covariate for our subgroup or not, yes or no. For this example, we're going to use the Math Exam 14W dataset from PsychoTools. I like saying that, PsychoTools. Now, they have a funny way of storing the solved data. They keep it in like more of a set notation aspect. So I went ahead, I converted it. Now, something I do in this is I rearrange the order of the columns so that they go from the one with like the fewest questions correct, the one with the most questions correct. Why did I do this? Well, by doing this, actually, I have it from most correct to least. The reason why I do that is that it's easier to spot things that are not going with the trend if I have them sorted by the global overall variable. And so here I make my data frame, and you'll notice that I'm using item resp from PsychoTools. Now here what I'm doing is I'm getting rid of the case where they got every single question right or every question wrong, because their parameter values aren't going to make sense and they're just going to befuddle the rest of the analysis. So I went ahead and got rid of it. And these other covariates, I am converting to ordinal data. Now I'm going to actually build the tree model. I'm using this Psycho tree package. And you'll notice that it's part of the party like collection of tree functions. Okay, so the reason why this is important is because this package gives us a lot of features if I want to start really digging in, start rolling up my sleeves and getting into this modeling structure. Now here I'm going to build the model. Now, if you look here, you can see this is the textbook's version of the formula. We have a lot of things. I have a problem with this model. Why do I have a problem with this? In solved is going to be the output from the solved questions. And so there's a circular aspect here. So I feel like in solved should not be included. So I got rid of that. When I ran the model, only group and tests were included in the final model. So when I'm running this, as I build up these HTML files multiple times as I'm editing, and just to get to run faster, I just reduce this down to group and tests. And here, this is things, parameters for the tree that I can tinker with if I choose to. And so we can look at the item parameters. And I can visualize it. All right, so first thing I notice is that right off the bat, the very most important single variable for this data set is group. I conclude that there is bias in this. Now, is it bias towards group 1, bias towards group that favors group 2? I don't know, but I conclude that there's something biased going on. Then after that, it's tests. So the number of tests they've taken. And you'll notice that since I sorted everything, there is a trend here. There's a trend here, and there's a trend here, though it's weaker. All right, so the reason why I sort things is that when I look at this, when I see a value that goes against the trend of all the other points, that's one I want to dig in personally and look at more closely. Now, the next one, what this does, this shows how large of a factor value does the individual have to get a 50-50 chance of getting the question correct. And so since I sorted everything, you can see that there's overall a trend on the bars going from left to right. Now, it's not a perfect trend, but when I see that things are going against the order, those are the questions I would specifically want to start digging into. Well, that's all I've got for you. Take care and goodbye.